Okay, let's begin talking about relativity. Okay, so Galilean relativity works like, if I'm on a skateboard and I'm moving at 20 meters per second, and I throw a ball at 10 meters per second, an observer looking at me will see the ball moving at 20 plus 10 equals 30 meters per second. Just look at the ball. So are we sure that it's moving at 30 meters per second now? Well, now even that becomes even more relative, because even then the Earth is spinning at a certain velocity, and it's also revolving around the sun at a certain velocity, and also the sun is revolving around the center of the galaxy at a certain velocity. So that means that in no way is this going to be 30 meters per second, and this will all be relative. So in conclusion, velocity can never be absolute, and it's always going to be relative. Now, does that mean that some crazy scientist is running at you with 100 meters per second and is shining a flashlight at you? Does that mean that the flashlight is shining light at you, c plus 100 meters per second? So does that mean the flashlight is traveling faster than the speed of light relative to you? No, and here we're going to learn that c is always going to be constant and it is absolute. Looking at light as a wave, starting at this point of origin, moving outward in its medium called the ether, it is clear that light should act just like this, going at every direction in a constant speed c. And if the origin moves, light should behave as if like this, which is moving faster this way, moving slower another way, relative to the origin. And since Earth does move, and it is clear that that's how light should act, moving faster in one direction and slower in another. However, some kooks did an experiment to prove this, and they came up with the conclusion that no matter where you are, light always travels outward at c, no matter the velocity of this guy. So this guy could be traveling at 100 meters per second, and if he moves in this direction, light would still travel in c, and if he moves in this direction, light would still travel in c. And with that, we can conclude that c is always an absolute constant, no matter your frame of reference. Now, having an absolute velocity can literally blow everything out of proportion, and everything you think can completely become false, just by making absolute velocities real. So look, let's say this is here's a time box. We're gonna call this a time box, and the distance right here is d, and it's gonna take 1 second for this photon to travel there and back. Let's say Albert Einstein has one of these time boxes, and then I have one of these time boxes on a skateboard, and I move at a certain velocity this way. So for this to travel this distance, and this to travel this distance, it takes 1 second for this to travel up there. So that took 1 second, and that took 1 second for this to travel up there. However, the speed of light is always equal wherever you are. So distance over 1 second equals distance over 1 second. Doesn't make any sense. Why? Because we can clearly see that this distance is greater than this. Now, if these two are equal, and this is bigger than that, that would mean that it should be clear that this second is greater than this. That means that if 1 second was 1 second for Albert Einstein, 1 second would be 2 seconds for me. And seconds, we're looking at an outside point of view. So we can clearly see that although the same amount of time has passed for me, time is slower compared to Albert Einstein as compared to me. Thus, it's not velocity that's relative, it's mathematical. Now, we can clearly see that right here, here, and here, these three are going to make a right angle triangle, which can be displayed right here. This is depicted as the velocity of light multiplied by my time, right here. This is depicted by the velocity of light multiplied by Einstein's time. And this is depicted by my velocity times my time, that's right there. And with this, we can easily isolate for the time of Einstein as compared to the time of me, with the constant being right here. And this is referred to as gamma. Now, as such, using this constant, we can see that as things move closer to the speed of light, that light is always going to distort mass, it's going to distort length, etc. And all of the variables will deal with this constant right here, comparing the velocity that it's traveling at over the speed of light squared. It's also clear that if this velocity exceeds that of light, then this number would be greater than 1, which is going to result in 1 minus a negative number, a square root of a negative number, which is also infinity, which cannot be done, and the theories state that if that was achievable, that we'd move backward in time. However, as of right now, that's completely impossible. So looking at gravitation, Einstein proposed that any mass is just distortions throughout space, and that's exactly what gravity is that things attract each other not because of a force, but because of distortions in space-time.